It's really funny how we treat our bathrooms. Above the sink, everything is just like completely pristine.
Oh, that was
Flawless chrome, matching towels, perfectly clean surfaces. We control that environment, absolutely. But the second water goes down that drain, it enters this totally dark, mysterious, hidden underworld of pipes and traps that we just completely ignore.
Right up until the water stops going down.
Exactly.
And suddenly that, hidden underworld becomes your very immediate, very stressful problem. We like things to be visible and manageable. When they aren't, the instinct is usually just to panic.
Which usually means either pouring some terrifyingly harsh chemical down the drain and just like hoping for the best, or immediately calling a professional and handing over your credit card.
Yeah, the two extremes.
Right. But today, we are changing that dynamic with a deep dive into some truly empowering source material. We've got our hands on a fantastic, highly detailed tutorial from a seasoned professional plumber over at the How to Plumbing channel.
It's a great resource.
It really is. And we are unpacking their ultimate DIY homeowner's guide to fixing a slow-draining bathroom sink.
The goal here is to give you, the listener, a complete step-by-step diagnostic toolkit. We're looking at really a masterclass in troubleshooting, moving from a completely free 5-second trick all the way to advanced plumbing surgery inside your walls.
Because everyone deals with clogged sinks, but most of us just don't understand the actual mechanics of the plumbing in our own homes.
No, we really don't.
By the end of this deep dive, you are going to understand exactly how your sink works, how to fix it, and potentially save yourself upwards of $425 in the process.
Which is a nice chunk of change.
For sure. But before we start ripping apart pipes or cutting into drywall, our source insists that we start with the absolute simplest fix, the plunger.
It's the tool everyone reaches for first, yet in a bathroom sink, almost everyone uses it incorrectly.
I am completely guilty of this. Because plunging a sink seems, entirely self-explanatory. You just put the rubber cup over the drain and push.
Right, but the tutorial points out a crucial feature of almost every bathroom sink that just completely defeats your plunger if you don't factor it in.
The overflow hole.
Exactly. That small hole near the upper rim of your sink, the one designed to let water escape if someone leaves the faucet running with the stopper closed, it's directly connected to the main drain pipe just below the stopper.
It functions as a built-in safety valve to prevent flooding.
Yeah, and that safety valve is exactly what sabotages you when you grab a plunger.
So?
Well, think about what a plunger actually does. It forces a sudden, high-pressure wave of air and water down the pipe to physically dislodge a clog.
Right.
If you just plunge the bottom drain, fluid dynamics dictate that the pressure will take the path of least resistance.
And the path of least resistance is?
Right back up the overflow hole.
Oh, wow, of course.
The pressure just shoots out the top of the sink, totally bypassing the clog down below. You are essentially just splashing yourself with dirty sink water.
I've definitely done that.
Most people have. To effectively plunge, you must seal the system.
It's a really clever trick when you visualize the mechanics of it. Yeah. It's like trying to blow up a balloon that has a hole in the side of it.
That's a great analogy.
You can blow as hard as you want, but unless you put your finger over that hole, you can't build up any directional pressure inside. You have to seal the system to force the air where you want it to go.
Exactly. So the plumber in our source uses a simple wet rag to completely cover and plug that overflow hole before plunging.
Just a wet rag.
Just a wet rag. By covering that secondary escape route, you force all of that plunging pressure straight down the drain line. For a lot of minor clogs, this completely free 5-second intervention is entirely sufficient to clear the line.
That's so simple. But okay, since this is a deep dive into troubleshooting, we have to keep moving down the diagnostic path. Let's say you seal the overflow, you plunge like crazy, and the water is still just sitting there staring at you.
The simple fix failed.
Right. So we have to physically go under the sink and start taking things apart. We are entering the domain of the P-trap.
This is the part that usually scares people off.
Oh, absolutely.
Looking under the sink and seeing all those curved plastic pipes. But the tutorial breaks it down brilliantly. First, you pull out the pop-up plug lever.
That's the little horizontal rod pulling the stopper up and down, right?
Yeah, exactly. Pulling that rod out gives you a straight, unobstructed shot right down the drain.
And according to our source, 90% of clogs in homes under 10 years old happen right there in that vertical drop.
Yeah, it's mostly an accumulation of hair, soap scum, and debris catching on the stopper mechanism itself.
Gross.
Very gross. So to get to it, you unscrew the P-trap, and the tutorial stops to define what a P-trap actually does, because it's not just like a fancy curved pipe to catch lost wedding rings.
Right, it serves a really vital health-saving function.
It does. A P-trap, which looks like a letter J or P, depending on the angle, is deliberately designed to hold a small pool of water in the bottom of its curve at all times.
Because that pool of water creates an airtight seal.
Exactly.
Without that water blocking the pipe, highly toxic and, let's be honest, terrible-smelling sewer gases from the main city line or your septic tank would drift straight up the pipe and into your bathroom.
It would be awful. The P-trap is literally a water shield protecting your house from sewer gas.
And clearing it out is shockingly low-tech. In the video, the plumber just uses a wire coat hanger and a bit of tissue to push all that nasty gunk out of the trap and the straight pipe above it. It takes, like, a couple of minutes.
It's a very fast process.
Okay, hold on. I'm looking at the source material here. $425.
Ah, yes. The reality check.
Our source says, if a professional drain cleaning service comes out to your house to literally unscrew a plastic pipe and pull out a hairball with a wire, it costs $425. I mean, that borders on extortion.
It sounds outrageous when you isolate that one specific 2-minute action, but we have to reframe what you are actually paying for with professional services.
Okay, explain that to me.
If it is just a simple hairball in the P-trap, a sympathetic plumber might cut you a break. But you aren't just paying for the coat hanger trick. You're paying for their travel time, their vehicle overhead, their liability insurance.
And crucially, their expertise to know exactly where to look.
Right. And they also have to cover the cost of all the expensive equipment sitting in their truck.
Sure.
$425 is the going rate because they have to assume they will be hauling out their heavy, expensive machinery to clear a deeper blockage. They don't know it's just a hairball until they get there.
That makes sense.
This illustrates exactly why learning to check the P-trap yourself is so highly valuable for you. If you can eliminate the simple local problems yourself, you avoid that massive baseline call-out fee entirely.
Okay, so let's say you've done a work. You cleared the overflow, you plunged, you took the P-trap off, you used the coat hanger. The trap is completely spotless.
Okay.
You put it all back together, turn on the faucet, and the sink still drains slowly. Worse, it makes this weird noise.
Ah, the dreaded bloop.
The bloop. The tutorial focuses specifically on this sound. It's a distinct glugging, blooping noise coming from the drain.
This is where we shift from basic maintenance into advanced diagnostics.
Because that sound is a massive clue, right?
Huge clue. A completely clear local drain that still drains slowly and makes a bloop sound indicates a partial stoppage much further back in the line, usually inside the wall itself.
Wow. Inside the wall.
Yeah. I like to look at it like a medical symptom. The bloop isn't the disease itself, it's the house trying to tell you that the issue isn't local anymore, it's systemic.
The bloop sound is literally the sound of the drain gasping for air.
That's a perfect way to describe it.
Plumbing systems require air ventilation to flow properly. It's just like when you try to pour oil out of a large can, if you don't punch a second hole in the top to let air in, the oil glugs and splashes uncontrollably.
Right, that air needs to replace the fluid.
Exactly. If there's a clog further down near the vent stack, the water struggles to displace the air, causing that gasping, bubbling sound.
And in the specific bonus scenario covered in the source material, the plumber starts investigating this deeper issue and discovers a total nightmare.
Oh yeah, this part was wild.
The bloop wasn't just a clog. The drain pipe behind the wall had actually disconnected entirely.
Just totally separated.
Yes. Water was just dumping inside the wall cavity, causing rot and damage to the wood framing.
That is the absolute worst-case scenario for a homeowner. To fix a systemic issue like this requires opening up the drywall to expose the plumbing infrastructure.
And the tutorial gets into the tools here, which is fascinating.
Right. The plumber mentions how they used to use an old-school keyhole saw, basically a handsaw, to hack into the drywall. Now they use an oscillating multi-tool.
It's a game changer.
It's a power tool that plunges a flat blade straight into the wall, vibrating incredibly fast.
The multi-tool allows for surgical precision. You can cut a perfect, clean rectangle, a template hole, so that patching the drywall later is significantly easier. You aren't just tearing jagged holes in your cabinet.
Which is nice, but the most crucial step the professional takes here happens before any pipe is cut.
The physical kiss.
Yeah. Once the wall is open, They physically reach in and vigorously wiggle the exposed pipe. They pull on it, they try to roll it back and forth.
You have to test the structural integrity of the rest of the system.
Right.
If you just start cutting out the bad section without testing, you might find that the pipe is rotten or disconnected another 3 feet down inside the wall.
And then you're really in trouble.
Exactly. You have to ensure that the pipe you are going to attach your repair to is completely solid. Otherwise, you're just chasing the break further and further into the house.
Okay, so let's say the surrounding pipe passes the wiggle test. We have an open hole in the wall, exposing a broken pipe in extremely tight quarters. How do we actually perform plumbing surgery in a space that small?
Carefully.
I mean, I'd probably just try to pry the pipes apart, jam a new piece of pipe in there, and tape it up.
And that would guarantee a massive leak behind your wall within a week.
Fair enough.
It requires highly specific materials. To patch a disconnected line permanently, the plumber uses a new 1.5-inch piece of PVC pipe, a 90-degree elbow, and couplings to join the new pieces to the old line.
And there is a massive distinction to make here regarding those couplings.
There really is.
The tutorial highlights the slip coupling, because a standard pipe coupling has a tiny ridge or a stop right in the middle of its inner ring. This ensures that when you push two pipes into it, they meet exactly in the dead center.
Which is fantastic if you are building a system from scratch and have room to bend the pipes to fit them into the coupling.
Right.
But inside a wall, you can't bend anything. The existing pipes are rigid and locked in place. You can't wedge a standard coupling into a fixed gap.
That's where the slip coupling comes in.
Right.
It has no inner ridge.
Yeah.
It is completely smooth on the inside.
Exactly.
I mean, you can slide the entire coupling completely up onto the top pipe, totally out of the way. Then you align the bottom pipe perfectly underneath it and just slide the coupling back down so it bridges the gap between the two.
It's a brilliant little fitting, but the assembly relies entirely on a chemical bonding process, specifically the use of primer and cement.
Okay, talk about primer.
The primer they use, usually that purple liquid you see stained on pipes, it doesn't just clean the dirt off the plastic. It is a highly volatile solvent.
So it's not just a cleaner.
No, it cleans the PVC, but it also chemically attacks the plastic. It softens and actually heats up the surface of the pipe.
This prepares the plastic so that when you apply the actual glue, the solvent cement, the two pieces of pipe don't just stick together. They literally melt and fuse into a single continuous piece of plastic.
It creates a chemical weld. The bond is permanent.
Okay, but if it literally melts them together instantly, I'd be terrified of putting that elbow joint in slightly crooked.
It's a valid fear.
Once it's in, you can't twist it to adjust the angle. Are you just eyeballing it in that tiny cabinet space and praying it points toward the sink?
Never. Professional plumbers never rely on guesswork. You dry fit everything first. You never apply glue until you know the geometry is perfect.
Okay, so how do they do that?
Our plumber does this by taking a random 3-inch piece of scrap pipe and inserting it into the new elbow without any glue.
Oh, I see. They stick that dry scrap piece so it protrudes right through the hole in the cabinet wall. They literally use the physical hole in the wood as an alignment jig.
Exactly. By referencing the hole itself, they guarantee the elbow inside the wall is aiming perfectly straight at the sink connection.
That is so smart.
Once the alignment is visually confirmed, then and only then do they prime and glue the permanent connections inside the wall.
Doing this requires cutting the pipes to exact lengths in these tiny, cramped spaces. They recommend a small, battery-powered reciprocating saw, which is like a miniature motorized hacksaw, though a manual hacksaw works if you have the patience.
We must note the safety warning highlighted in the source.
Oh, right. The fumes.
Working inside a cabinet with your head near the hole in the wall, applying chemical primer and cement exposes you to intense fumes. The volatile organic compounds can overwhelm you in a tight space.
It's serious stuff.
You must have active air circulation, a fan, or an open window to work safely.
Okay, so the surgery is a success. The broken pipe in the wall is patched, perfectly aligned, and fused together. We should be done.
You would think so.
But if we turn the water back on right now, that bloop is still going to be there? We fixed the collateral damage, but we totally ignored the original disease.
Right.
The deep, partial stoppage that caused the bloop sound in the first place is still lurking down in the main line.
So it's time to bring out the heavy artillery, the professional drain machine.
The source uses a Milwaukee battery-operated drain cleaning machine. It looks like a heavy-duty power drill attached to a spinning drum of metal cable.
And the crucial feature of the cable, the snake, is the design of the tip. It's called a drop head.
which showcases another amazing piece of physics. When you push a metal cable blindly into a pipe in the wall, it eventually hits a T-junction, right?
Yeah. The pipe goes up to the roof to vent out sewer gas, and it goes down to the sewer line to carry away water.
So if you use a standard straight snake, there's a 50-50 chance the cable just shoots straight up the vent pipe toward your roof.
Which doesn't help anyone.
No. You could snake all 25 feet of cable and hit nothing but open air.
Exactly. The drop head is weighted and hinged. When it hits that vertical junction, gravity pulls the head downward. It forces the cable to travel down into the actual drainage system where the clog lives.
And the technique is surprisingly gentle, isn't it?
Very. The professional doesn't just jam the machine on full power. They hand feed the 25-foot cable slowly into the pipe until they physically feel resistance.
So it's about touch.
You rely entirely on tactile feedback transmitted through the metal cable to your hands. You feel when you've hit a change of direction like an elbow, or when the cable physically bites into the actual stoppage.
Amazing. Once that deep clog is chewed up and cleared out by the spinning cable, we finally get to reassemble the entire sink trap.
The fun part.
Right. But the tutorial mentions something during reassembly that captures like the entire spirit of DIY repair. When the plumber goes to put the new P-trap on, they mention Murphy's Law of Plumbing.
Ah, yes.
Why do plumbers always buy 2 of everything when they go to the hardware store?
It's the ultimate realist mindset required for home improvement. The rule is buy 2 cans of glue, 1 to kick over and 1 to use.
That is the absolute truth. If something can go wrong, it will. If you drop a tiny vital washer and it rolls under the floorboards, and you only bought 1...
Your entire project is paralyzed.
Speaking of washers, there's an interesting historical detail during the reassembly. The plumber uses a 1.5-inch by 1.25-inch reducing washer to connect the modern pipes to the older sink drain.
Yeah, decades ago, the standard plumbing size for bathroom sinks was 1.25 inches. Modern building codes and materials have shifted to a 1.5-inch standard.
I mean, 1/4 of an inch doesn't sound like it would make much of a difference.
In fluid dynamics, it makes a massive difference. Because you are calculating the area of a circle, expanding the diameter of a pipe by just 1/4 of an inch drastically increases the total volume of water it can handle.
Oh, wow.
It provides significantly more flow and vastly reduces the chances of debris clogging the line. Whenever you replace a trap today, you are upgrading to that larger, superior standard, using that special washer to adapt it to your old sink basin.
That's super interesting. Okay, so let's recap the journey we just took.
Let's do it.
The next time your sink stops draining, you aren't going to panic or reach for the drain cleaner. You're going to start by taking a wet rag, covering that overflow hole, and forcing directional pressure down the drain with a plunger.
And if that fails, you're going to grab a bucket, unscrew the P-trap, protect yourself from those sewer gases, and use a simple coat hanger to clear the local blockage.
If you hear that dreaded bloop sound, if the drain is gasping for air, you now know how to recognize a systemic issue.
You understand the mechanics of slip couplings, bridging fixed gaps, the chemistry of PVC primer melting plastic together, and the directional physics of a drophead drain snake navigating blind intersections.
You are armed with a diagnostic escalation path. You can confidently tackle the minor issues yourself, keeping that $425 service fee in your wallet.
Just as importantly, if the issue really is deep inside the wall, you now know exactly what the professionals are doing and why their expertise, tools, and materials are actually worth the cost.
Absolutely. Which brings me to a final thought for you to chew on today. We've just spent all this time talking about how frequently pipes clog, leak, or completely disconnect behind the walls, causing catastrophic water damage.
It is an absolute inevitability of homeownership.
Water systems require constant maintenance.
They absolutely do. Components degrade over time.
Right. So given that certainty, why has modern home architecture evolved to seal our most critical failure-prone water infrastructure behind impenetrable, pristine sheets of drywall?
That's a great question.
We literally build our homes in a way that requires us to destroy the walls just to maintain the basic functions of the house. Is it time we completely rethink how homes are built? Should our plumbing be easily accessible behind decorative panels rather than hidden away in that dark underworld we are so desperate to ignore?
It's a design philosophy that prioritizes aesthetics completely over functionality. As we've seen today, when functionality fails, the aesthetics have to be cut apart with a saw.
Very true. Until we start building houses with maintenance in mind, you're going to need that diagnostic toolkit. Keep the overflow hole plugged, listen for the bloop, and always buy 2 cans of glue. Thanks for taking the deep dive with us.